Hello, my name is Diana Atieno Owino. I'm currently undertaking Diploma in Mathematics and Statistics. I'm going to present on matrices. So, the learning outcome, by the end of the session, the learner should be able to define matrix, element of a matrix, and the order of a matrix. Number 2 is to explain on the type of matrices. Number 3 is to perform operation on matrices. And lastly, on outline application of matrices. So, matrix, definition of a matrix. A matrix is a rectangular array of numbers, symbols, or expression arranged in rows and columns. I have here a basic example of a matrix, that is a 2 by 2 matrix. So, matrix A, it has 2 rows and 2 columns. The first element is 1, the second element is 2, the third element is 4, and lastly, the fourth element is 1. We are going to define the order of a matrix. The order of a matrix is given by the number of rows times the number of columns. For example, you have matrix A. It has 2 rows and 3 columns. So the order of this matrix A is given by 2 by 3. So that is how you identify the order of a matrix. We go to define the element of a matrix. The element of a matrix is the value in the I row and the j column. Example, I have given matrix A. It has element 1, 3, 4, and 5. So if you have been told to identify the element in the first row and the first column, you will choose element 1 because element 1 is in the first row and the first column. For example, if you have been told to identify element 4 it is in the second row, the second column. So that is how you identify the element of a matrix. We are going to the type of matrices. Number 1, we are going to talk about the row matrix. The row matrix is given by 1 row and the n number of columns. For example, matrix A, it has 1 row and it has 4 columns. That is the row matrix. We go to the column matrix. The column matrix is given by 1 column and n number of rows. For example, matrix A, it has element 2, 3, and 7. This matrix A, it has 3 rows and 1 column. So that element is a column matrix. We have square matrix. A square matrix is given by the same number of rows and column. For example, matrix A, it has element 1, 2, 3, and 4. So it has 2 rows and 2 columns. So this is a square matrix because it's of 2 by 2. When you have 3 by 3, 4 by 4, that is also a square matrix. We go to the identity matrix. Identity matrix is 1 with 1s in the leading diagonal and 0 in the other diagonal. For example, matrix A, it has element 1, 0, 0, 0, 1, 0, 0, 0, 1. So it has 1 in the leading diagonal and zeros in the other diagonal. So that is identity matrix. We go to the matrix operation. We are going to talk about addition and subtraction for today. So addition of a matrix can be added if they have the same order of rows and column. So a matrix can be added if the order of the matrix has the same number of rows and column, and we are going to add corresponding elements together. For example, matrix A has element 1, 2, 7, 6, matrix B 2, 3, 9, 8. So this is a 2 by 2 matrix and B is a 2 by 2 matrix, so the order is the same. So A plus B, we are going to take element 1 in the first matrix and element 2 in the second matrix. We add. We are going to take 2 in the first matrix and 3 in the second matrix. We add. We are going to take 7 in the first matrix and 9 in the second matrix because they are the same element. Then we are going to take 6 in the first matrix plus 8 in the second matrix. So when we add 1 plus 2, we get 3, 2 plus 3, we get 5, 7 plus 9, we get 16, and 6 plus 8, we get 14. So that is how we do addition of matrix. We also have subtraction of matrix. Subtraction of matrix is the same as the addition of matrix. We are going to add matrix of the same order. For example, matrix A, it is of matrix A has element 7, 8, 7, 6, and matrix B has element 5, 6, 4, 5. So we are going to subtract element in the first matrix minus the element in the second matrix. So we are going to take 7 minus 5, 8 minus 6 in the second column. We are going to take 7 minus 4, 6 minus 5. So A minus B is given by 7 minus 5 is 2, 8 minus 6 is 2, 7 minus 4 is 3, and 6 minus 5 is 1. Going to the application of matrices. So matrices is applied in the real life situation, for example, in solving linear equation, in computer graphics, in economics, in the input and output model, in statistics and data science. So in summary, we have defined what is a matrix, the order of a matrix, types of matrices, operation on matrices, and lastly application of matrices. We also discussed the importance of understanding matrix basic, where we have said that it's used in solving system of linear equation in statistics. And then lastly, I'm going to leave you with this discussion question. In which real life situation have you encountered the use of matrices? Why is it important to understand matrix application rules rather than just applying them mechanically? Thank you so much. That is my presentation. May God bless you.